Good evening, my dear subscribers, followers, colleagues, students, ladies and gentlemen. This is video number 384, and today my main focus will be on the role of technological progress in economic growth and development. Let me define technology. Technology is the application of knowledge for achieving practical goals in a reproducible way. The word technology can also mean the products resulting from such efforts that include both tangible tools such as machines and intangible ones such as software. It plays a crucial role in science, engineering, and everyday life. The term dates back to the early 17th century, and it is predated in the use by the ancient Greek word techne, used to mean knowledge of how to make things, which encompassed activities like architecture. In the 20th century, technology was thought of as the systematic use of knowledge to practical ends. In the economics of growth and development, the term technology, denoted by T, is the way how inputs are transformed into output by the production process. Let us assume we have the production function given by the equation y is equal to f of k L and dot. Then the technology of the production function is given by the function f of dot. In the Cobb-Douglas production function given by this function y equals k raised to the power alpha, al whole raised to the power 1 minus alpha. In this case, a can be thought of as an index of technology. A new idea that allows a given set of inputs to produce more or improved output may be thought of as technology. Now let us define technological progress, which refers to the discovery of new and improved methods of producing goods and services. Changes in technology lead to an increase in productivity of labor, capital, and other factors of production. Technology, as was defined earlier, refers to the process through which the inputs are transformed into outputs. Increased application of new scientific knowledge in form of invention and innovations with regard to both physical and human capital. Such progress has been a major factor in stimulating the long-term economic growth or the sustained growth of the contemporary developed world. There are three phases of technological progress. The first one is invention, which is the act of creating new knowledge, and it involves a new scientific or technical idea and the means of its embodiment or accomplishment. The second phase of technological progress is that of innovation, which may refer to discovering a new way in which to use or apply the existing technology. Rogers thought of innovation as an idea, behavior, or product that appears new to its potential adopter. The third and the final phase of technological progress is diffusion, which pertains to the spread of technology throughout a society or industry. And it is the process by which a new idea, product, or behavior is accepted by the market. Technology diffusion also means the spread of usage or application of new technology from its current user to others. Now we will discuss the types of technological progress. Technological progress may be labor-augmenting, that raises the productivity of an existing quantity of labor by general education on-the-job training program, and so on. Labor-intensive technique is a method of production that uses proportionately more labor relative to other factors of production. Then we have labor-saving technological progress, which is the achievement of higher output using an unchanged quantity of labor inputs as a result of some invention or innovation. Technological progress may be capital-augmenting if it raises the productivity of capital by innovation or inventions. Capital-intensive technique, which is a process of production that uses proportionately more capital relative to other factors of production such as labor or land per unit of output. We may also have labor-saving technological progress that results from some invention or innovation that facilitates the achievement of higher output levels using the same quantity of inputs of capital. Then there is scale-neutral technological progress that can lead to the achievement of higher levels of output irrespective of the size of a firm or farm. And it makes it equally applicable to small or large scale production process, and it doesn't matter whether the size of the firm is small or large, it equally is applicable to the size or scale of the production process. Then we may have Hicks-neutral technical change, and it is the change in the production function of a business or industry that satisfies certain economic neutrality conditions. The concept of Hicks neutrality was first put forth in 1932 by John Hicks in his book The Theory of Wages. It can be defined as a change that is Hicks neutral if the change does not affect the balance of labor and capital in the production function, and more formally, given the Solow model production function, we may write y is equal to A times f of k L. A Hicks neutral change is one which only changes A. Now in this slide, we may compare three different types of neutral technological progress. One is Hicks neutral. The first equation shows Hicks neutral technological progress, and it may be thought of as renumbering or relabeling of the isoquants without any change in their shape of the function in the labor and capital space. Then we have Solow neutral technological progress, and Solow neutral technological progress is capital-augmenting progress. Here, isoquants shift with the technological progress in such a way that they have constant slope at a given labor output ratio. So Solow neutral technical progress is capital-augmenting technical progress. Then we have Harrod-neutral technological progress, which increases output as if the economy had more labor. Slope of the isoquants are constant along rays with constant capital output ratio. In the coming slide, we will see diagrams of the three, that is Hicks, Solow and Harrod-neutral technological progress. So if you look at this slide, there are three diagrams. The first one is Hicks neutral, where in the production function only the technical progress only the technological progress only shifts A. Then we have Solow neutral technological progress, which is capital-augmenting, and finally we have Harrod-neutral shifts in isoquants, and that is labor-augmenting technological progress. We may also explain it a little bit more. Technological progress or technical progress is Hicks-neutral if the ratio of marginal product of capital and divided by marginal product of labor is constant for a given capital labor ratio, as if isoquants were being renumbered or relabeled. And it may be given by this production function, where AT changes over time, and that can be completely factored out of the function f of L and K. Technical progress or technological progress is Harrod-neutral if it is labor-augmenting, as I mentioned earlier. Relative factor shares constant at any capital output ratio, and it can be given by this production function. Finally, we have Solow-neutral if it is capital-augmenting, relative factor share constant at any labor output ratio, and we may give that by this production function, where y is equal to function of labor AT times K. This is a capital-augmenting. Sorry, this should not be F, this should be Y, and here we should have F. So the progress production function is such a illuminating production function which has all the three properties. It could be Hicks-neutral, it could be Harrod-neutral, or it could be Solow-neutral. Let us now discuss the difference between embodied and disembodied technology. So first we focus on embodied technology, and it means the knowledge and skills that are used to create products and equipment, including software. This also means that the technology is not just something that exists on its own, but instead a part of things we use every day. For example, the technology used to create a smartphone is embodied in the phone itself, making it possible for us to use it to communicate, take pictures, and access the internet. Say for example, increase in the quantity of quality of labor is also an example of embodied technical change. Technical change in this sense that results in an improvement in the quality of capital or labor, and here technology is regarded as endogenous, not like manna from heaven. This is different from disembodied technology, which refers to knowledge and skill that are not directly tied to a physical product or piece of equipment. Here, technology is not regarded as endogenous, but as exogenous. And this is the technical change that results in a change in the production process. The attempt to measure the contribution of technical progress was made by Abramovich in 1956, followed by Kendrick and Solow. These economists consider the technical progress to be disembodied. Disembodied technical progress is one which allows more output to be produced from the same inputs. So, disembodied technical progress is based on the assumption that all labor and capital are homogeneous. It improves the productivity of all factors and of those already in existence. In case of disembodied technology, technical knowledge is assumed to come from the outside the system, like the falling of manna and salva from the heaven. That is, if the rate of the technical progress depends on non-economic factors, it can be regarded as exogenous rather than endogenous. So in Solow types of model, technical progress is thought of as exogenous, while in case of Paul Romer and Charles Jones, new growth theory, technology or technological progress can be thought of as endogenous. Ladies and gentlemen, in this video, we discussed the definition of technology, the various phases of technology, the various types of technological progress, that is embodied and disembodied, then labor augmenting, labor saving, capital augmenting, capital saving, capital deepening and labor deepening,